So, good morning everybody. Myself Acharya Vishvendra, and today I'm going to discuss a worksheet on translational equilibrium. So, let's begin with the worksheet. So, here is the worksheet on translational equilibrium. So, the first question is condition for translational equilibrium. So, the condition is that net force is equal to 0. Next is under translational equilibrium acceleration is, so net force is ma, so acceleration will be 0. Next is types of translational equilibrium. So they are basically three types, and just like as shown in the graph. The first is the unstable equilibrium, which corresponds to maximum potential energy, as you can see over the graph. Second is the stable equilibrium, which corresponds to minimum potential energy as given by the second graph. And neutral equilibrium, at which potential energy is constant. So we can say that at unstable equilibrium, potential energy is maximum. At stable, potential energy is minimum. And at neutral equilibrium, potential energy is constant. So if we analyze the graph, we can say that potential energy is maximum at point 1, minimum at point 2, and constant at point 3. Next is the relation between force and potential energy. So the relation is F is equal to negative du by dr, or negative of slope of UR graph. If we see over here that there is a graph of potential energy versus the distance between the particles, there are 3 points in it, A, B and C. So if we analyze the 3 points, if we draw tangent to the curve at this particular point, then we can say that this tangent makes an angle which is greater than 90. So the slope here is negative, and since force is equal to the negative of slope, the force will be positive over here. At point B, theta is equal to 0, so slope will be 0, so force will be 0. Whereas at point C, angle is less than 90, the slope will be positive, and hence force will be negative, because force is equal to negative of slope. Next is we have certain points A, B, C, D, E, F. Then the first question is we need to find at which point U is positive. So as we can see in the graph, U is positive at A and B. The next question is at what point U is negative. So it is negative at D and D. Then at next question, at what point U is equal to 0. So it is 0 and C at C and F. Next is F is positive. So F is minus du by dr, which is negative slope. F is positive, that means slope is negative. So as we can see in the graph, slope is negative at points B and C. Next is F is negative at what point? So if F is negative, slope will be positive, which is given by point E and F. Next is F is equal to 0. So F will be 0 when slope is 0, which is 0 at A and D. Next is stable equilibrium. So at stable equilibrium, potential energy is maximum, so it will correspond to point A. Next is unstable equilibrium. At unstable equilibrium, potential energy is negative, which corresponds to point D. Next is non-equilibrium position. So B, C, E, F are the non-equilibrium positions here. And next relation between force and potential energy is F is equal to minus of du by dr. So these are the certain graphs or the graphical based question on the concept of translational equilibrium, or on the potential energy versus distance graph. So these are just optimization tools for optimizing your time and energy. I hope this will be beneficial to you in improving your results. Thank you and have a nice day.